Imagine, if you will, staring out into an endless ocean. But instead of water, it's the vacuum of space, and instead of boats, it's galaxies, swirling nebulae, and the faint whispers of light from the dawn of time. This is the observable universe, the portion of the cosmos we can, in principle, see from Earth. But what lies at its edge? What profound secrets are hidden within the furthest reaches of space and time, just waiting to be uncovered? And what has NASA, with its cutting-edge technology and insatiable curiosity, found lurking there, challenging everything we thought we knew about our place in the cosmos? Our journey starts now, at the very edge of understanding. Before we can explore the edge, we need to define what we mean by it. The observable universe isn't a physical boundary in the traditional sense. It's limited by the distance light has had time to travel to us since the Big Bang, roughly 13.8 billion years ago. Because the universe is expanding, those distant objects are much further away than 13.8 billion light-years. In fact, the edge, the cosmic horizon, lies an astonishing 46.5 billion light-years away in all directions. This means that light from anything beyond that horizon simply hasn't had enough time to reach us. It's as if we're standing at the center of a vast, ever-expanding bubble. But if we can't see beyond it, how can we possibly know anything about what lies there, or even at the edge itself? For decades, scientists have relied on telescopes, both ground-based and orbiting, to peer into the deepest recesses of space. The Hubble Space Telescope, for instance, gave us unprecedented views of some of the earliest galaxies, shining brightly just a few 100 million years after the Big Bang. But even Hubble had its limits. It could only see invisible and ultraviolet light, which is absorbed by dust and gas in the early universe. To truly probe the edge, we needed a telescope capable of seeing in infrared light, a telescope powerful enough to pierce through the cosmic fog and reveal the secrets hidden within. A telescope like the James Webb Space Telescope, the most ambitious and complex scientific instrument ever built. But what exactly makes the Webb so special, and how does it help us see the unseeable? The James Webb Space Telescope, or JWST, is a marvel of engineering. Its primary mirror, composed of 18 gold-plated beryllium segments, is over 6.5 meters in diameter, vastly larger than Hubble's. This allows it to collect far more light, enabling it to see fainter and more distant objects. Crucially, JWST is designed to observe primarily in the infrared, allowing it to see through the dust and gas that obscure our view in visible light. Think of it like having infrared goggles that allow you to see heat signatures in the dark. With this capability, JWST can peer back in time, observing the first stars and galaxies as they formed in the early universe. But what startling discoveries has this incredible instrument already made at the edge of the observable? One of the most surprising discoveries made by JWST at the edge of the observable universe is the abundance of surprisingly mature galaxies. Astronomers expected to see smaller, less developed galaxies in the early universe, gradually growing and merging over billions of years. Instead, JWST has revealed galaxies that are already remarkably large and complex, with well-defined spiral arms and supermassive black holes at their centers. These behemoths are far more massive and mature than models predicted, challenging our understanding of how galaxies form and evolve. But if these galaxies are more mature than expected, does that change what we thought we knew about the early universe? The existence of these early, massive galaxies throws a wrench into our understanding of structure formation in the universe. Current cosmological models suggest that galaxies form through the gradual accretion of smaller clumps of matter, driven by gravity. But the rapid appearance of these massive galaxies suggests that this process might be more complex and efficient than previously thought. Perhaps there were mechanisms at play in the early universe that we haven't yet fully understood. This has led to new theories suggesting that dark matter, the mysterious substance that makes up the bulk of the universe's mass, might play a more significant role in galaxy formation than we initially believed. But how does dark matter affect galaxies anyway? Dark matter, though invisible, exerts a gravitational pull on ordinary matter, influencing the formation and evolution of galaxies. One hypothesis is that dark matter halos, large concentrations of dark matter, acted as scaffolding for the first galaxies, providing the gravitational seeds around which ordinary matter could coalesce. The presence of these massive dark matter halos in the early universe could explain the rapid formation of large galaxies observed by JWST. Furthermore, interactions between dark matter particles themselves might have played a role in shaping the distribution of matter in the early universe. Exploring these possibilities requires pushing our theoretical models to their limits. But could even more exotic forms of matter and energy be at play at the edge of the universe? Beyond dark matter, there's the even more enigmatic dark energy, a mysterious force that's causing the expansion of the universe to accelerate. We know relatively little about its nature, but it makes up roughly 68% of the universe's total energy density. Studying the distribution of galaxies at the edge of the observable universe provides clues about the influence of dark energy over cosmic history. By measuring how the expansion rate has changed over time, we can potentially constrain the properties of dark energy and gain a better understanding of its fundamental nature. Could observations at the edge of the universe allow us to solve the greatest mystery in cosmology? Looking towards the edge of the observable universe isn't just about discovering galaxies and understanding dark matter and dark energy. It's also about probing the very earliest moments of the universe, approaching closer and closer to the Big Bang itself. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, a faint radiation that permeates the entire universe. It represents the furthest back in time we can directly observe. Studying the CMB provides invaluable information about the conditions that existed in the infant universe. What secrets does this afterglow hide? The CMB reveals tiny temperature fluctuations, representing regions of slightly higher and lower density in the early universe. These fluctuations acted as the seeds for all the structures we see today, from galaxies to galaxy clusters. By analyzing the patterns and statistical properties of these fluctuations, scientists can test different cosmological models and gain insights into the processes that shaped the early universe. For example, the size and distribution of these fluctuations provide evidence for a period of rapid expansion called inflation, which occurred in the first fraction of a second after the Big Bang. It's like reading the fingerprints of creation. But how can we be sure about the story these fingerprints are telling? The quest to understand the edge of the observable universe is far from over. New telescopes, both on the ground and in space, are constantly pushing the boundaries of our knowledge. Future missions, such as the Roman Space Telescope, promise to provide even more detailed observations of distant galaxies and the expansion history of the universe. As we continue to probe the depths of space and time, we can expect even more surprises and challenges to our current understanding of the cosmos. The universe, it seems, is always more complex and fascinating than we can imagine. What mysteries lie just beyond the horizon, waiting to be revealed? So, what has NASA found at the edge of the observable universe? Not a definitive answer, but a profound and humbling perspective. It's found galaxies far more mature than expected, hinting at new mechanisms of galaxy formation. It's found clues to the nature of dark matter and dark energy, the mysterious components that dominate the universe. And it's found a deeper understanding of the Big Bang and the conditions that gave rise to everything we see around us. The journey to the edge is a journey to understand ourselves, our origins, and our place in the vast and awe-inspiring cosmos. And it's a journey that has only just begun, promising to unlock even greater wonders in the years to come. Perhaps one day we will truly understand our universe. Until then, we can only keep looking, keep questioning, and keep exploring.